The fact that the world's coldest continent was just as warm as Italy might surprise you. A layer of ancient fossils uncovered near the South Pole, more than half a mile below the ocean in a location that was once covered in ice, tells a shocking story about the coldest continent on Earth. Although the South Pole's average winter temperature is currently 78 degrees below zero, only 90 million years ago, Antarctica was home to a thriving jungle.
What I find most striking is the presence of Antarctica on ancient maps.
Long-lasting winter darkness in the region Antarctica was in an exciting period. At that time, it was essentially the last time that vegetation and possibly even fauna, including dinosaurs, blanketed the entire continent. On the other hand, scientists are uncovering previously unknown aspects of Antarctica. Could history be repeating itself as Antarctica becomes warmer? Due to climate change and its massive ice sheet shrinks, come with us as we uncover the hidden path that scientists have found, leading to an Antarctic jungle winding through valleys and hills sculpted by long-gone rivers, even before the Ice Age. Antarctica was a continent devoid of ice, actually. It looked more like a tropical forest, with towering trees and a wide variety of animals millions of years ago. How can we tell we know? Through the relic hunting process, several significant fossils were recovered by Captain Scott and his crew near the Beardmore Glacier in the Trans-Antarctic Mountains. Before they perished in 1912, on their return, trek from the South Pole, prehistoric seed. Fern tree fossils were unearthed. During the retrieval and analysis of this collection, the existence of such vegetation on the continent indicates that it was significantly warmer in the past. Additionally, the fact that these fossils are so similar to Glossopteris, fossils discovered in South America, South Africa, and Australia, lends credence to the theory of continental drift, which was advocated by Alfred Wager and proposes that the continents were once connected but have since drifted apart. Our current understanding of tectonics and the processes underlying continental drift was born in the 1960s. Throughout geologic time, the positioning of Antarctica has changed due to seafloor spreading and subduction, just like that of other continents. As a result, the continent has never always been placed above the South Pole. Tectonic plate patterns and configurations have indeed changed significantly throughout the course of geological history. As an example, some 450 million years ago, the crust of Antarctica spanned the equator, and the crust of England was in the southern hemisphere, Gondwana. The southern portion of the supercontinent, Pangaea, was formed around 200 million years ago, when the continental crusts of Antarctica, South America, Africa, India, and Australia were connected. At some point after this, Gondwana began to break apart, becoming Antarctica as its own continent. Since then, the southern continents have given way to Antarctica, which has been slowly drifting towards the poles. While it is true that a continent must be in a polar location to form an ice sheet, this doesn't explain the extreme cold of the continent or the extent of the ice cover. To get a complete picture, we need to consider other massive changes in Earth's atmosphere and geography that help to seal off Antarctica's climate and reduce the amount of heat that got there from lower latitudes. The Antarctic plate, of which the Antarctic continent is a part, is one of the 7 main tectonic plates on Earth. The Antarctic plate is made up of the oceanic crust beneath the oceans that encircle Antarctica and the continental crust that makes up Antarctica and its continental shelf. When did Antarctica enter its deep freeze, and what caused it? In order to fully understand the range of reasons that led to the early Jurassic period, it is important to briefly review Antarctica's tectonic history. About 180 million years ago, rifting began to split Gondwana apart. By 150 million years ago, a sizable sea had formed between Antarctica and Africa, separating the African and South American continents. Northward movement of the Indian subcontinent following its breakup from Antarctica, approximately 125 million years ago, marked the beginning of the American continents. during the later Cretaceous period, approximately 100 million years ago, marked the beginning of Antarctica's crust's separation from Australia and New Zealand. Antarctica will have passed over the South Pole by now. Of vast oceans separated Antarctica and Australia about 40 million years ago. During the Terre-Ar period, the Antarctic Peninsula broke away from southern South America approximately 35 million years ago, creating the Drake Passage because of the lower amount of solar input at higher latitudes and the larger seasonal variations in brightness. The climate of the continent changed as it migrated to its current location, yet even at its most recent, over 100 million-year-old location, the temperature was substantially higher than it is today, up to 85 degrees. South fossils have been found that point to polar woods that existed at different points in time. Thus, the current frigid climate of Antarctica cannot be explained just by its location. Rather, we need to look at the bigger picture to see what changed the world's climate from the Cretaceous period to now. A warmer lower atmosphere spread across the entire world around 100 million years ago prevented the accumulation of glacier ice. Everywhere, due to the significantly higher concentration of carbon dioxide and other greenhouse gases. Compared to today, also the land SE configuration close to Antarctica allowed warm currents to reach high southern latitudes, which helped to temper the polar temperature. The division of the South American continent into the Antarctic Peninsula and the expansion of the ocean between Antarctica and Australia are two major tectonic events that also account for Antarctica's cooling. Because of these shifts in the combination of land and sea, the icy circumpolar current was able to form and begin its clockwise journey. Greenhouse gas concentrations have been steadily declining since the end of the Miocene, when they were at their highest. Trends downward since at least 55 million years ago. The Antarctic ice sheet's journey around the continent, which blocks the coast from warm water glaciers, is thought to have begun some 38 million years ago during the late Eocene, based on research into continental rock formations and ocean-bottom sediment deposits. Recent remains of tundra plants found in the McMurdo Dry Valleys, however, suggest that the climate was similar to that of the modern-day southern tip of South America even as late as 14 million years ago. The East Antarctic ice sheet reached its maximum size approximately 13.8 million years ago, and shortly after this, as Antarctica cooled even further, the West Antarctic ice sheet reached its maximum expansion around 6 million years ago. This occurred much earlier than in the Northern Hemisphere. Tectonic activities, a reduction in greenhouse gas emissions, and changes to the Earth's general energy balance and atmospheric circulation pattern were all important contributors. Whatever the case, researchers have discovered a remarkable 20-armed organism that bears a striking resemblance to a strawberry at the bottom of the Antarctic Ocean. This remarkable creature, officially named Promachus gregarius, has piqued the interest of scientists and is colloquially known as the strawberry feather star. The study team retrieved their nets from the frigid Antarctic Ocean, where they discovered the species.